All right, for slide 2 of the toxin research project, your job is to research the toxicology of your toxin. And so the slide 2 instructions are shown here. In slide 2, you need to actually add slide 2 to your Google slide deck, title it toxicology. And then on the slide, you need to do some research, and then explain how the toxin interacts with the human body at various different levels. So we're looking at the body as a whole system, the body as a collection of body systems, so effects on specific organs as well as at the cellular level. We'd like to know how the toxin acts on cells. So which cells is it acting on? And then how is the toxin metabolized? Is it metabolized by cells of the kidneys or liver? Is there some other way that the toxin is metabolized? And this is a good time to point out that maybe we don't know. Depending on your toxin, you may not be able to find this information, and that's okay. The important thing is that you look and that you document that you did look. You explain how you looked. If you have trouble finding information, include the search terms that you tried when you did your search, and that way in the future somebody else can pick up where you left off and hopefully either take the research further, or maybe they'll be inspired to fill in the gaps. If there's gaps in the research, then hopefully somebody out there will start to fill in those gaps so that we can expand our knowledge in science. Okay, so once we know how the toxin interacts with the body, we'd like to know whether there are treatments available for people who are exposed to the toxin. If there are treatments, explain how they work. If there are not treatments, if you can't find anything, maybe you're able to find information that says, we tried a certain treatment and it didn't work, and here's what we tried. It's very possible, again, that depending on your toxin, that maybe there's no treatment available at all, in which case, again, that's good information for somebody out there who's feeling inspired to contribute to medicine, and perhaps they can then come up with a treatment. Okay, again, important, document your work, so always cite your sources for any information that you find, and cite or explain how you tried to search in case you can't find something. Include your search terms that maybe didn't work, so that search can be reattempted in the future. Okay, so with all that behind us, for slide 2, how would I approach it for the toxin that I've been researching, which is caffeine? Well, here we go. I would enter into a Google search the term caffeine metabolism. So for you, put the name of your toxin and then the word metabolism. Metabolism meaning how the body processes that particular toxin. What happens at the cellular level or above. So I put in caffeine metabolism, and there's a lot known about caffeine, so I'm pretty fortunate here. The very first thing that pops up in my Google search is part of a Wikipedia entry for caffeine. And my personal philosophy on Wikipedia is it's a fantastic place to start. I have no problems with a student starting off with Wikipedia. I think that's the entire point of Wikipedia. Back in the day, we would start off with an encyclopedia, a paper encyclopedia, and I know that the set that I used when I was a young student was 20 years old and dusty, and so I'm sure it was at least as I'm sure Wikipedia is at least as accurate as that old set of encyclopedias that I used to use. The difference is that those encyclopedias were proofread. There was a lot of quality control, and so they were at least thought to be accurate as of when they were published, whereas because Wikipedia is an online resource that anybody can edit, there's always the potential that information on Wikipedia is not accurate. That being said, there have been studies done that have shown that Wikipedia is at least as accurate as information published in the medical journals. So my recommendation, if you've got a good Wikipedia entry, which this one looks good to me, start there, but don't stop there. Use it as a launching point and then dig in. Look for the actual primary sources. Okay. Caffeine is metabolized in the liver by the cytochrome P450 oxidase enzyme system, in particular the CYP1A2 isoenzyme. So there's my enzyme right there, CYP1A2, and there's my target organ, the liver. The liver is where this enzyme exists, and it breaks caffeine down into 3 dimethylxanthines, each of which has its own effect on the body. So I'm looking at these three images. I've got a lot to go on here. I'm going to click on this first image, or actually if I click on this first image, it's going to take me through a series of more things to click on. So if I really want to know more about this, where I've got what looks like caffeine at the top, three different metabolites at this middle level as a result of the enzyme CYP1A2. I see there's some additional CYPs. The text is really small, but these are additional enzymes that further break down these metabolites into the three metabolites that are shown. And then there's further metabolism. And so I'd like to know, like, what is going on there. So I'm going to note that this image is coming out of pharmacological reviews. So I'm not in Wikipedia at this point. This information was collected for me in Wikipedia, but at no point have I actually accessed Wikipedia. I'm using the primary sources that Wikipedia is collecting for me, or has been collected on Wikipedia. So if I jump into the pharmacological reviews article and I look for this image, I can find it here. I'm going to save you the trouble of watching me dig for it, but it is in that article. And I am interested in knowing, like, what's going on here. So you can see that in this journal article, the scientific journal article, there's a number of different sections. We've got caffeine metabolism and pharmacokinetics, the effect of various factors on caffeine metabolism. These are things that I want to know about. I see metabolism. That was part of my initial search. I want to do some reading. So I'll read on that. I can see in here, I found the image, and around the image, I've got a lot of information about the CYP1A2 enzyme, which is found in the liver. And I can see that it's actually a really, really important enzyme in the liver. It represents 15% of all the cytochrome P450 in the human liver, and it accounts for more than 90% of caffeine metabolism. So at least 90% of the caffeine that somebody ingests is going to get processed by this CYP1A2 enzyme. And once it gets ingested and broken down by that enzyme, it's going to produce these three different metabolites. And so that's going to be right in here. So 84% of the caffeine that gets metabolized gets broken down into paraxanthine, 12% gets broken down to theophylline, 4% gets broken down into theobromine. And there's going to be additional information about what those three metabolites do. Again, depending on how deeply I want to know about caffeine metabolism, I could continue to research these three metabolites and find out what exactly do they do on the body. For this tutorial, I'm not going to go that deeply. My expectation is not that you will go that deeply, but I would encourage you to. If you've got the time and the interest, go for it. This is learning. Okay, so we know that caffeine affects is processed by the liver, metabolized by the liver, and it's metabolized by a specific enzyme, the CYP1A2 enzyme, as well as some additional enzymes after that. What does it do to the body as a whole? Does it act on specific organs? Does it act at the cellular level? This is where I could probably find some more information about this in here. In fact, if I were to go up into the introduction, I would find additional information about that. But let's say I'm having trouble with that. Maybe your toxin doesn't have one article that contains everything that you're looking for. Another thing you can do, another search you could do, would be to Google the word Pubmed. It's a related site to Pubchem. It's all part of NCBI. So if you put Pubmed into your Google search bar, you'll come up with the first link here. Pubmed is part of the National Center for Biotechnology Information. It's a government-run website, part of the National Library of Medicine, and it is a massive database that basically has a catalog of all of the different journal articles that are published. So it's a really important resource for research scientists. Okay, so let's see. I'm going to go for caffeine metabolism. Click on that. All right, and then PubMed is telling me that there's 16,844 results for caffeine metabolism. That is more than I want to deal with. I'm going to go ahead and click on free. I'm all about free. Some of these articles, actually a lot of these articles, you have to pay for. Only 5,000 of these are free out of the 16,000 that were there. And I'm going to focus on review articles. I'm interested in focusing my efforts. I want to look and see what other people have collected into a bank of information. So now I'm down to 188 results, which is still way more than I'm going to be looking at. But I'm going to go ahead and take this first one. All right, so caffeine, cognitive and physical performance enhancer or psychoactive drug. Let's see, I'm going to take a look at the abstract. Suggests that the concepts of toxic and lethal doses are relative. Well, I'm all about lethal doses, so this looks like it could have some information that's of interest to me. So what I'm going to do is actually click on the free full text link. And I'd like to look at this the way somebody might if they were actually reading this journal. So I'm going to click on the PDF. Okay, so now it's all nicely formatted the way it was originally intended when it was published. And I've got my title. This was published back in 2015, so it's fairly current. It's part of the Journal of Current Neuropharmacology, so it's a recognized scientific journal. And I can look through the introduction. So just like you write a lab report, this is effectively a big lab report. So they've got a nice introduction, which looks like it's focusing on caffeine as it relates to coffee. The world consumes 1.6 billion cups of coffee a day. That's a lot of coffee. So I could continue to read through this. Looks like there's a little history going on here. It's kind of fun. Going back to the year 1025, so it goes way back. I'm just skimming this. Looks like there's a guy that drank up to 50 cups of coffee a day. So that's a lot of coffee. Probably not something that you want to do. And the intro continues. And now we're getting into some of maybe the more speculative things about what caffeine might do. So we'll see where this goes, but I'm already noticing on the right-hand side as I continue through. So the methods are just like our procedure section in a lab report, and then we've got the results. All right, so I'm skimming this. I'm looking for results. I see CYP1A2. Now I'm starting to get interested. I'm skimming through this. Caffeine's pre-systemic metabolism is negligible. Once it's absorbed, it promptly gets into all the body tissues and crosses the blood-brain barrier. So that tells us that it can be effective or active on the brain. CYP1A2 accounts for 95% of caffeine clearance. So we saw earlier 90%, so it looks like it's as high as 95%. Caffeine's half-life in humans ranges from a minimum of 2 hours to a maximum of 12 hours. So when you drink coffee, it's going to take at least 2 hours for half of that caffeine to be gone. When you drink anything with caffeine, it's going to take at least 2 hours for that caffeine level to peak and then start to decline. And in some people, it looks like it can last as long as 12 hours, mainly due to the inter-individual variability in absorption and metabolism. So people metabolize caffeine differently. That shouldn't come as a surprise, right? We all have our own genetics, and so the way that we metabolize caffeine or the products, the metabolites that come after CYP1A2 breaks down caffeine, that's going to be different for different people. I'm looking here and I see that 84% paraxanthine, 12% theobromine, and 4% theophylline. So again, those are those three metabolites that I saw earlier in the figure that I was looking at. Let's see. Okay. So if I wanted to learn more about paraxanthine, I could do that here. I'm not going to read through that for you, but if you're interested, you could follow the same path. And I'm going to continue looking through. There's some additional CYP enzymes. I'm going to come back up to the next column. All right, now I'm getting into mechanism of action. The potential effects of caffeine at the cellular level can be explained by three mechanisms of action. The antagonism of adenosine receptors, especially in the central nervous system, which would include the brain, the mobilization of intracellular calcium storage, and the inhibition of phosphodiesterases. So now we're getting into the nitty-gritty. Like, this is the biochemistry of caffeine. All right, we could continue. We're just going to glance at this for a moment. Caffeine blocks adenosine receptors, completely antagonizing their action and causing an increased release of dopamine, noradrenaline, and glutamate. All right, so this starts to get pretty heavy. At this point, I'm gonna back out of this so that we don't get it too far into the weeds. You could continue reading about intracellular calcium mobilization as well as inhibition of phosphodiesterases. And for those of you thinking about going on and taking additional science, you should challenge yourself to read through a review article like this. This is really good information and will help you as a student and as a scientist down the road. Okay, so let's see here. Getting back into what I'm asked to do for this slide, explain effects on the body as a whole, on specific organs, and at the cellular level. So I think I've covered that. How does does the toxin act directly on cells, and if so, how? Well, one of the things that I could talk about for that section would be this antagonism of adenosine. And the reason I find this interesting is because actually on our class website, I already looked at that. That's something that's been hiding in plain sight for you for quite a while. Back when we were shut down and awaiting guidance on how to move forward with our learning, I put together the Steampunks section. And so if you click on that, there are these 5 different components of steam. The very first post I put together was on sleep, something that all of us probably want more of. Even now, when we should have access to all the sleep we can possibly get, it's still kind of hard to sleep with the weirdness of this shutdown. If you check out the PBS Nova episode, The Mysteries of Sleep, it's about an hour, well worth the watch. You could also watch this TED Talk, which is just like 5 minutes. And within this TED Talk, this is or TED Ed Talk, they will talk you through the relationship between caffeine and the adenosine A2A receptor. And so that is information that I have compiled into my slide. So I took advantage of what I learned from this, and you should too. But I put that information in. So use your resources. Use YouTube if there's some quality information. TED, I trust things that are on TED Ed. I trust things that are in Pubmed. And I even trust things that are on Wikipedia, as long as I can source them. So I use that to finish up this section here. All right, as far as treatments available to people who are exposed to the toxin. Well, I learned from this article that that caffeine has a half-life in the body of 2 to 12 hours. And so I've done additional research, and I found that there really aren't any treatments available. I did a search for treatment for caffeine overdose, and really the treatment is just supportive care, just making sure that somebody who takes in too much caffeine and might be feeling the acute toxic effects of rapid heartbeat, diarrhea can be a side effect, anxiety can be a side effect. So making sure that people have access to the support that they need while they're metabolizing caffeine naturally in their body. That's really the treatment. The UW Medicine website has a link what to do when you've had too much caffeine. So I checked that out. This is not necessarily like an intense science kind of link, but it does have information that suggests that 400 milligrams of caffeine is too much, and maybe why you feel jittery. And if you have significant symptoms that you just cannot control, then go to the emergency room or have somebody take you. But really, in terms of treatment, drink lots of water, take a walk, practice deep breathing, and wait it out. And then maybe reevaluate whether you should be drinking so much caffeine. Okay. There are definitely toxins that are out there that will have treatments, and so you want to make sure that you, if you can, find those for your toxin. Again, if you can't, then explain what you did to search for treatments and explain that you were unable to find anything based on your search terms. Let's see. If you can't find anything regarding treatment, propose a treatment and explain your thinking. So one of the things that people can do in terms of caffeine would be to drink decaffeinated beverages. So not necessarily a treatment directly, but it is an option that people have rather than taking in caffeine if it's something that they have a difficult time managing or processing themselves. Okay, so all that being said, I will post an example slide of what I compiled for caffeine, so you have something to look at for how to handle slide 2. And if you have any additional questions, please email or attend office hours. Good luck.